Okay, we have another integral today. This one's from Caltech Math Meet 2025, finals number 30. We have the integral from 0 to pi over 2, 1 over cosine squared x plus 2025 dx. Okay, this one, it was kind of straightforward, but the interesting thing is I got a totally different solution than the Caltech Math Meet. I'm kind of thinking they have an error either in the problem or the solution or both. I'm not really sure. So to get started with it, my first step was I got to do my favorite thing, which is multiply in secant squared over secant squared just to clean this up. The reason this works so nice is it usually sets up a u sub for us, because if we can get tangent, the derivative of tangent is going to be secant squared dx. So let me just rewrite. We'll have in the numerator now secant squared x dx. Now the other good thing here is secant squared times cosine squared, that's just going to be a 1. And then over here we have 2025 secant squared. But again, because I want to do a u sub, I want this to be tangent, but we can just use the identity and create it. And I can write this as tan squared x plus 1. So from here, I think I'll just do that u substitution and kind of clean it up later when we do the sub. So here I want to substitute for tangent so that we have u equals tan x. And then that way du is going to be the whole numerator, secant squared x dx. So when we do this, first plugging in pi over 2, tan pi over 2 is going to infinity. Plug in 0, tan is 0, 0. Then again, the whole numerator becomes du. And then let me kind of rearrange this part. So this thing here, this is going to be u squared times 2025. So let's see. So we'll have 2025 u squared. Distribute 2025 into the 1. We get 2025 plus 1 equals 2026. But to set up an arctan integral, I can just factor 2025 out of the numerator. It's a little messier than the way this usually works, right? Because, the u squared's fine, but then this is going to become 2026 over 2025. In order to set this up like an arctan integral, let's write this as the square root of this whole thing, all squared. I'll go ahead and integrate, but I need to be a little careful with this mess over here. So we have 1 over 2025. Then we're going to get the reciprocal of this. Now the square root of 2025 is just 45. So when I flip it, we'll have a 45 here over square root 2026. Then we're going to have arctan of u times this same reciprocal. So actually, let me write it like, it's actually not going to matter because we have infinity and 0 here, but let me just write it anyway. So we have 45u over square root 2026 evaluated from 0 to infinity. Now when we evaluate this, when we evaluate arctan at 0, the whole thing is going to be 0, so we don't care about that. And when we evaluate at infinity, this whole mess doesn't really matter because we're just multiplying finite numbers on an infinity, so this is going to be pi over 2. So what we have is going to be 45, just plugging in with this in front, 45 times pi over 2. This is from the pi over 2. I kind of separated, but that's pi over 2 times 2025 square root 2026. Now we said before that 2025 is 45 squared. So I can actually basically just cancel that with like one of the 45s and we're left with 45 here. And so putting it all together for my final solution on it, we just get pi over 90 times square root 2026, and that's it. So now, like I said, I did confirm this with Wolfram Alpha based on this original problem, but what they had is totally different. They got square root of 2 over 13 times pi. I can't really find any relationship there. Although in the original problem, they had it like it was an indefinite integral. The only thing is there's no way to have an indefinite integral and then come out with a constant value with no x. It doesn't really work. So basically, I don't really know what happened here, but let me know if you have any ideas, or maybe it's just a mistake, and that's fine too. Okay, that's it for today. Thanks so much for watching. Have a good day.